Welcome, everyone. The event is now live. John, please take it away.
Thanks, Annie. Hi, everyone. Welcome to the latest installment of our ongoing editorial webinar series, Coffee Talk. Each hour-long, information-packed episode organized by the hardworking folks at Redmond Magazine features the observations and insights of an independent expert on a wide range of tech industry topics. Many thanks to the underwriting sponsor of this episode, high-performance enterprise networking solution provider, Juniper Networks. Without their support, this series would not be possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of the Converge 360 Group of 1105 Media, and I'll be your moderator. Today, we're bringing you the Data Center Automation Crash Course, how to get almost hands-free data center management. And our lead presenter is technologist, creator of compelling content, and senior resultant, Howard M. Cohen. But before we get started, just a bit of housekeeping. This episode is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way in the next few days. We'll make some time at the end of each presentation for questions, but please feel free to type your questions into the Q&A box at any time. We'll do our very best to get to all of them. Our sponsor has provided some extra resources you won't want to miss. They're available now in your console. And as a small thank you to the first 200 attendees who stick with us to the end, we will be sending you a $5 gift certificate to Starbucks. It's a cup of joe to go with the info. Now I'd like to introduce our first presenter. Howard M. Cohen has spent more than 40 years in the IT industry. During that time, he has held senior executive positions at many of the top channel partner organizations, and he currently writes for and about IT and the IT channel. He's a sought-after speaker and insightful observer of the technology landscape, and one of our very favorite presenters. You're in for a great session. Take it away, Howard.
Thank you, John, and hello, everybody. Welcome to our presentation today. As John said, I'm Howard M. Cohen. I'm a creator of compelling content who spent 40 years in the IT channel and writes about it and writes for it now. The two QR codes you see there will take you to more information about me, and I hope you'll check them out. Those of you who have attended my sessions in the past know that I love to begin with a word of the day. And today's word, if you haven't guessed it already, is volume. Pump up the volume. No, I'm not going to pump up the volume, and we're not going to blare any music behind me. I'm not talking about a volume of sound. I'm talking about a volume of data. And if you reckon, this is an example of a data stream coming in from a typical server across the network. There's tons of traffic constantly crossing the internet, and that generates tons and tons of data that's constantly coming through your network. And the data center is meant to capture all that data, log it, and so keep a record of everything that's gone into and out of the data center. Now, it's one thing when we think about a server, right? It's a very small, it's not even a data center, it's a network room. A closet maybe. But what if you have 2, 3, 4, 5? What if you have 500 servers? You know, many data centers have had hundreds of servers, and each one of them is generating data constantly, and there's data coming across the internet toward them constantly. That's an awful lot of data. To put the challenge best, I'll share a quote from our friends at Red Hat. Red Hat has said, as IT systems continue to evolve and grow, and we all know the evolution of technology hasn't stopped in 50 years, and it shows no sign of slowing down. And as it evolves, it grows. More and more people adopt more and more technology. And as the scale grows, as the size grows, the complexity is growing right along with it. And that becomes harder and harder to manage. So at this point, you know, I love the way they say the sheer volume of data these systems generate is overwhelming. And indeed, that's the problem. It's all overwhelming. There's no way people can keep up with it. Try to imagine sitting at a console watching this data and getting any meaning out of it as you do. It's crazy. Without sufficiently intelligent monitoring and analysis tools, and that's the key sentence here, there's a deep, deep need for sufficiently intelligent monitoring and analysis tools. If you don't have them, you're going to miss alerts. When you miss an alert, a problem goes unchecked. That can turn into a disaster. You miss opportunities to improve things, and that's going to cost you one way or another. And of course, you're going to experience a lot of downtime, and downtime is very, very, very costly. So the problem is a big one. Well, what I'd like to do, you see that sentence, sufficiently intelligent monitoring? I'd like to focus in on that word intelligent, okay? Because it's all about adding intelligence to the way in which we manage the data center. And when we talk about an intelligent data center, or when we talk about intelligence and the data center, it's really a two-way street we're talking about. Okay, what do I mean? On the one hand, we obviously need artificial intelligence and machine learning to help us better automate the data center so we can run better, so that we don't have to capture all that data. Maybe it can capture all that data, and with enough intelligence, it can analyze that data and determine what actions need to be taken to remediate problems. Great. On the other end of the argument, we need better data centers, more intelligent data centers, to better support artificial intelligence run applications. Artificial intelligence is needed to make a better data center. Better data centers are needed to make better artificial intelligence. It's kind of a catch-22, but it's one we're going to have to manage. So to bring that all together, I grabbed up a Gartner diagram that illustrates the role of the data center in today's business world. And of course, the data center performs all of its classic functions. It manages the servers, the storage, the routers, the switches, the CSU, DSUs, all the different equipment that it takes to operate a network. And that's all still in the data center. But more recently, and I'm talking 25 years, instead of expanding the data center and getting more space, many companies have opted to use a co-location facility and put some of their equipment there. So they're not paying as much in rent or heating and cooling or electricity. They're simply paying a fixed fee on a regular basis to a co-location facility to house some of their network infrastructure. And the data center still manages it from where they are. In some cases, the colo can manage it, but that's not what we're talking about today. Now, when you think about a co-location center, of course, ultimately, your mind is going to turn to the cloud. Because if you think about it, the cloud really represents the biggest co-location facility imaginable. Servers in thousands upon thousands, maybe millions of data centers all around the world at this point. And you can connect to any one of them. And basically, when you do, the original NIST definition tells us that you're probably using software as a service. So the application's running in that far, far-flung data center, but your users are using it on their PCs and tablets and smartphones. Or you're using the infrastructure in those data centers to replace infrastructure that you would otherwise have to buy. So many people are shedding capital investments and instead choosing to use infrastructure as a service delivered from a cloud data center. And many are also supporting their developers with platform as a service, providing them with the databases and the tools and the analytics and the languages, and also with the ability to spin up environments quickly for development and testing and so forth. So the original three models that the NIST definition of cloud talked about, they're still deeply in use today. And we're managing them all from our data center. In addition to that, of course, we have to talk about branch locations. Many organizations have had branch locations for as far as anybody can remember. And indeed, there's computing going on in those branch locations, and the headquarters data center usually has to participate in the management of those in some way, shape, or form. Now, the whole concept of a branch location took on a dramatically new meaning when we suffered through the COVID pandemic, and all of a sudden we had little teeny branch offices in all of our employees' homes. So instead of having hundreds of branch offices around the country, suddenly we may have had thousands of little branch offices with driveways. And we have to manage those too. The data center has to be concerned about those. And the fact is, a lot of those people are not coming back to headquarters. They're not coming back to an office. They like working from home. And it's become a far more efficient and far more cost-effective way for a lot of companies to work. So we're going to be managing that for a long time to come. Now, everything we've talked about so far has been about people on the network. Great. The fact is, though, that we have to look at the edge, the ever-expanding edge of the network. Used to be all the users in our building. Now the edge is global. We've created an Internet of Things. And this is not new. I constantly say this. There's a company that suggests that there have been more things on the internet than people since like 2008. And it's possible. But the fact is, there today, many more. We see all kinds of sensors and controls and switches and gauges. There's just tons and tons of stuff out there that your data center is now responsible for monitoring and managing. And most of those are little tiny things. They're very low powered. They're very lossy. They need a lot of help. And so the management burden on the data center just keeps increasing and increasing. And to sum it up, we're dealing with more endpoints than ever that need to be managed and protected because they're the most vulnerable points on the network. More applications are running of more types with more demands than ever before. If you have more applications running on more endpoints, you probably have a lot more users. Although these days, every user comes with 3 to 5 different devices each. And then finally, you take all of this together, and it's going to have to generate more data than ever. Because at the end of the day, we all know it's all about the data. And I'm talking big data. And yeah, John, I included the sizzling bacon slide just for you. John likes the sizzling bacon. Who doesn't like bacon? Everybody loves bacon. The only thing better than bacon is more bacon, and everybody loves data. And the only thing better than data is more data. So data is indeed the new bacon. And we need help managing all that data because people can't possibly keep track of it on their own. There's too much of it. And so we're talking about how to engage artificial intelligence and machine learning to help us manage the data. Why artificial intelligence? Because without it, technology can track ons and offs, thresholds being exceeded, simple stuff like that. But it can't detect relationships between things that have any level of subtlety. It can't interpolate or extrapolate. We need something that can really look at a pattern and read into that pattern what it means, what it's telling us. People can do that. People can interpret when they've seen the same pattern. They know how to recognize patterns. Well, so does artificial intelligence, except that artificial intelligence preserves it much better, remembers it much better than we can, and more of it, and can analyze much faster than we can. And so artificial intelligence has a big role. And in fact, it will change the shape, it will change the look of a data center control. We see a list here of all the different things that are going on in a data center. And we're looking at people sitting at consoles, each with multiple monitors, trying to keep track of all this stuff. And clearly, it's getting to be so much that this will not be the data center model of the future. We will not see tons of people sitting at tons of consoles for a variety of reasons. But then I'll ask you, how many of you want to be one of those people whose entire day is spent sitting at consoles trying to figure out what's going wrong. It's a difficult job. It's a demanding job. And any help, any artificial intelligence we can bring to help is going to be a really good thing. What these people are looking for is represented by the challenges that a data center faces. We've already talked about the first one. The first data center challenge, we talked about the volume of data that's coming at us every day. And the fact is that volume is only one of the three V's. It's not just the volume of data, which increases diametrically all the time. It's also the variety of different data types that we're facing, and that continues changing as well. And also the velocity. We're seeing data move through the network faster and faster. We're seeing improvements in bandwidth and processors and so forth. And so it's going to come bigger, faster, and in more different varieties than ever before. And that's not going to slow down. That growth is accelerating, and the acceleration is also accelerating. We're confronted with a huge maze that we have to navigate through. There's increasing complexity. I mean, we get better and better at this stuff. The systems we develop and the systems we put in place are more sophisticated all the time, and we would have it no other way. You know, that we crave more sophistication. We crave more compute power. We actually don't want to admit it, but we crave more complexity. But then we have to deal with it. And also, it's getting bigger. It's just growing all the time. Not only is it growing bigger, but it's growing more difficult to understand. The fact is that the sheer analysis of the data, the sheer analysis of the network and the components of the network and routing across the network and the nature of DNS. I mean, we're supposed to be shifting from an 8-bit word to a 64-bit word, and we haven't done that yet. IPv4 to IPv6 was supposed to happen 13 years ago. And because it's so complex, we've been delayed and delayed and delayed and delayed. And imagine the explosion of new capability that we'll get when we do make that change. But just analyzing the network has become so complex that few humans can actually understand it. And that's why we need artificial intelligence, which can gather the data faster, analyze the data faster, identify patterns within the data, and give us some meaningful reports so that we can take some useful action. Another thing is we're still in the forest, and we still don't know the forest from the trees. That is to say that all the things we do today look at the symptoms of what's going on our network. We see an anomaly. We see something working not the way it's supposed to. We see something coming in that's an unusual pattern that doesn't look like healthy data, or it resembles a signature that we've downloaded that we're comparing it against, because there are companies that are constantly detecting new signatures and sharing them with everybody, so that we have new signatures to compare with. That helps us identify symptoms. But the fact is that the more important identification is taking place under the ground, at the roots of the tree. That is, those are the causes, the things that are causing the symptoms we see. And the fact is, were we able to identify one cause and correct it, we'd solve for dozens of different symptoms. So it's a much more efficient way to proceed to really focus in on the causes than it is to focus in on the symptoms that are currently visible. Bottom line, you've all heard the phrase, we need to improve root cause analysis. We need to deepen, excuse the pun, we need deeper root cause analysis than we have today to help us get to a place where we're knocking down those symptoms faster than we ever have before. Okay, so once again, everything we're talking about so far talks about the way in which people are using the the network using the internet and the way the data center supports them, we can't leave out the edge. The edge has gone global. Literally any one of us can put edge devices literally anywhere if it can connect to the internet. And so we have these packets of different kinds of devices that we're deploying in all kinds of places. And there may be a whole bunch of sensors coming back to a concentrator that connects back across the internet to your data center. And as I said before, those are crappy little devices. They're very, very small. They're mass produced. They leach power from wherever they can. They tend to lose packets by the droves. They're hard to manage. But our data center has to take them on. And the bigger the edge gets and the more we try to reach across that global edge, the more difficult it's going to become for us to keep track of all that. Yeah, so we have to deal with the constantly expanding network edge. And for those of you trekkers amongst us in the audience, yeah, that is a picture of the Borg assimilated Earth. So you don't have to wonder about that anymore. Another challenge, or two other challenges that face us, are cybersecurity and compliance. Another thing that's increasing every day out there in the wild, woolly world of the internet is that there's an increase in security threats and an increase in compliance requirements. We're being victimized both by the internet itself, where bad actors, cyber criminals of all kinds, are launching new kinds of campaigns, new kinds of assaults. And we're victimized by the government, which is constantly inflicting new regulations upon us. And I'm sure for all very good reason. But the fact of the matter is that this is not one problem. This is two completely separate problems. For example, it is conceivable that you are fully compliant with all the regulations that your company is subject to. Congratulations, that's great. Doesn't mean that you're totally secure or even secure, very secure, secure at all. You know, the fact is that fulfilling regulatory compliance involves making sure that people are doing what they're supposed to do, and computers are doing what they're supposed to do, and everything in your operation is doing what it's supposed to do the way it's supposed to do it and operating within the confines of the regulation. That really has nothing to do with security, and very little to do with security. There's plenty that still has to be handled on the security side. And similarly, you may have the best imaginable security going on in your organization. It has no bearing upon whether or not you're really secure, you're really compliant with all your regulations. So security and compliance, two big challenges that you're facing, in addition to all the performance challenges and the operational challenges and so forth. And here's the one I think that's going to probably resonate with you best and probably aggravate you most, and that is red alert. Show of hands, how many of you have never uttered the phrase, "I'm sorry, I'm too busy putting out fires"? If you're in IT, you're putting out fires all the time. And put out enough of them, it leads to alert fatigue. You just get to the point where you're exhausted from constantly responding to all these emergencies that are happening. And alert fatigue is a real thing. And it diminishes your ability to concentrate on what's going on in front of you. And you may miss alerts, or you may misinterpret alerts, or you may misdetermine what you need to do about those alerts, and that's bad. So alert fatigue is a challenge. If we could take a portion, and by the way, several surveys say that there are more than 50% of companies today that get more than 50,000 alerts per day, and a quarter of them get more than 100,000 alerts per day. So we need to cut that down badly. And if we can get automation to do it, if we can get artificial intelligence to capture those alerts and action those alerts, we're way, way better off, especially because of the expectations of our user community. And that is to say that our user community expects what we affectionately refer to as rapid detection and response. Okay, well, what it really means, the user really expects, is that before they even realize there's a problem, you fixed it. And that is at best difficult. You're not this guy who can scan the world in an instant and come swooping in from space in seconds to solve a problem. But that really is what many users expect of us. And the problem is there just aren't enough of us to do that. The fact is that the skills gap, which we first started talking about in like 2006, 2007, well, here we are. And last year, I said that there are more than 4 million unfilled tech jobs around the world. More than 4 million jobs waiting for people to take them. That number is closer to 5 million now. And at least a quarter of them are here in the United States. We can't find people. We simply can't find enough well-qualified, trained people who can come in, participate in the data center, and help us solve all these challenges. And so even if we don't want to engage artificial intelligence, it's really all that's available to us. And even then, the artificial intelligence that's available to us now needs an upgrade. We need bigger, better processing power to keep up with it all, and that's coming too, right? You're looking at a quantum computer. And yeah, it looks a little bit like Robbie the Robot from Lost in Space, but that is a true quantum computer operating at unimaginable speeds. And we need those to drive more powerful data centers that can support artificial intelligence and machine learning, because we need artificial intelligence and machine learning to better support our data centers. We're back to that original catch-22. We need to pump up the processing power. And in closing, we've talked about artificial intelligence and we've mentioned automation. And people often ask me, well, which one is it? Are we going to use artificial intelligence? Are we going to use automation? Which one is it? And I don't know, I think it's becoming more and more obvious that it's artificial intelligence plus automation, the two together. Actually, it's automation driven, powered by artificial intelligence. And there's a word for that. It's, of course, another compound word, but it is today referred to as AI ops, using artificial intelligence to operate our data centers. Now, in the title of this session, we suggested that that could lead to hands-free operation. But we conditioned it there, and I'll condition it here to say that it's almost hands-free. Ultimately, we will get to a place where operating a data center is almost hands-free. A larger and larger proportion of it is being managed by the automation driven by artificial intelligence, but some of it still requires that human touch. In other words, we can look forward to seeing humans and artificial intelligence operating, ready for it, hand in hand. Okay, enough puns. As we gaze upon our friends here who are working together to operate our data centers, I'm going to turn back to John and ask if we have any questions from the audience. Oh, I already see, John, that our buddy Lynn is out there.
Shall we start with Lynn?
Sure.
Hi, Lynn. Welcome. Lynn is a frequent flyer. Just to remind everyone that they can type their questions into the Q&A box at any time. We'll do our best to get to all of them. Lynn is wondering, can you provide insights into the common challenges organizations face when transitioning to automated data center management and how they can overcome these challenges?
And for once, Lynn, I can say yes, I can answer that. It's not a book-length novel, so let me try. Uh, Basically, I think that incorporating artificial intelligence into a data center um, is like any other application we develop. That is, we do it step by step. We look at the low hanging fruit and we solve those problems first. And then we get up higher in the trees and solve those problems and so forth. We get more sophisticated as we go. But I also think we really need to look out into our IT world. Later this morning, you're going to hear from um, a developer. I'm going to use that as the right, I think it's the right word, who has invested a tremendous amount in creating and providing the kinds of tools we'll need to automate our data centers. And the kind of extensive research I think you're thinking about, they've already done. And it's reflected in the quality of their products and in the scope of their products. And you'll hear more about that very shortly. But I do think that it's like the journey of 1,000 miles begins with a single step. I think that's absolutely applicable here. You start off by automating the things that you can, the simple things, and then you let that teach you what can be automated next, and what can be automated next, and what can be automated next. I will say that partnering with a partner like our sponsor today can accelerate that curve for you tremendously. And that would probably be my best answer to your question today, Lynn. And thank you for the question.
Okay, here's one from Arnie who's wondering, how much does the continuing work from home movement really impact all this?
Yeah, well, I think we touched upon that when we talked about branch locations. The fact is that your attack surface has been redefined, or your threat surface, if that's what you like to call it. But the surface on which cyber criminals can attack you has grown from reasonable to massive, because it stretches to literally every place you have an employee who's connecting into your network remotely. That becomes part of your attack surface. And therefore, it needs to be managed by your data center. So while, I have to say this carefully, while the work from home phenomenon has benefited businesses tremendously and certainly benefited employees. I mean, businesses are getting more work out of their work from home employees than they ever got from employees who were traveling to a location, working at that location, and traveling home. I mean, just the travel time has turned into work time. So there's a benefit right away. The price they pay for it is having to effectively manage a much larger attack surface. Fortunately, the technology is there. It's not like it's something we dream of. It's something that the guys you're going to hear from shortly dreamt of and developed according to, and now can provide you with solutions for. So I think, it's not going to affect it's not going to affect our ability to manage our data center in a positive way, but our data center can be very ready for it, and it can really benefit our enterprise. Hope that helps.
Okay, I think we can squeeze in one more question. This is from Steve, who's wondering, will data centers themselves ever become obsolete?
Oh, the obsolete question. I was thinking about doing a new column, a new series called Future Obsolescence. It's I get questions like that all the time. Do you think this will ever be obsolete? Do you think that'll ever be obsolete? And data centers. I think as long as there's cloud, there will be data centers running those clouds, because when you come down to it, the definition of a cloud is a data center or data centers that are providing a specific service. And so when I hear cloud, I see data centers. In terms of will data centers owned and operated by companies ever become obsolete? I think most of those companies are hoping so. I don't know many companies that want to be operating their own data center other than technology companies. I know financial service companies, manufacturing companies, and other, professional service companies, and all kinds of companies aren't in the computer business, never wanted to be in the computer business, would love to divest themselves of their computer activities and would love to see somebody else handle it for them. And the fact of the matter is that many of you out there in the audience are raising your hands and saying, yeah, let us do that. Now, some of you are building your own capability to do that. Others are turning to the hyperscalers to do that. But net, you're still going to need your own infrastructure to be able to work hand in hand with the big cloud providers to deliver the right services to your customers. So we should look forward to data centers becoming obsolete in the wild, woolly world of business, but not in our lives or the lives of our cloud partners. That was a long way to that answer. I'm sorry.
That was a great answer. Thank you, Howard. We're going to go now to our next presenter, but before we do, I want to draw the attendees' attention to a poll question. You should be able to see now on your console. Your response would be greatly appreciated. Now let's meet Kyle Baxter, Senior Product Manager at Juniper Networks. Hi, Kyle. Tell you a little about him. Kyle leverages his expertise to drive innovation in network automation and orchestration, and he plays a pivotal role in developing cutting-edge solutions that empower organizations to optimize their network infrastructure efficiently. You guys are in for another great session. Take it away, Kyle.
Thank you, John, and great session, Howard. I really loved your topics and your presentation, so I do really appreciate that. So before we get into how at Juniper we can make your data center operations almost hands-free, I love that, want to understand and kind of help wake up the group here on what is your top motivations for network automation or wanting to know more about it or explore network automation. So you can see here various different answers. We'd love for you to pick them. You should be able to select on your screen and pick your options. Because just want to understand and help engage and see what are the pains that this group is looking for to solve. And then we'll see how within Juniper, how with the solution we call Apstra can bring that experience to your data centers. Now, John, what do you think is going to be the top answer here? Curious what you think people are going to pick.
I'd hate to guess. Let's see what they say.
All right. Well, let's see. So let's look at some of the answers. What we got. Surprising, the top answer: improving productivity, followed by reducing reliance on some of the key staff so they can free up to do other things. Another one that got a lot of response: improving velocity, reducing OpEx. Everybody loves to reduce cost. Another one, enforcing security and compliance policies. But answers pretty much across the board. Very interesting. So that's insightful. So let's actually get into what we're doing here at Juniper. So at Juniper, we believe in an experience-first data center. And what we mean by that is being able to provide a complete solution, and not just from a day zero of designing or a day one of building, but the continuous operation capabilities from your design to your deploy to your continuing to operate. Because what we believe is automation without intent and intelligence is really just pushing changes and errors faster. What you want is to be able to reliably be able to deploy your networks faster. And with being able to use industry standards and templates that we can provide with Apstra, you can get that speed and reliability that you expect, because everybody wants to be able to deploy services faster and make sure that they are actually reliable. That's a key. So the next thing is on experience. So Apstra is one of the pioneers of what's called intent-based networking. This means instead of driving your network via the CLI and knowing exactly every CLI command to configure BGP or whatever protocol you're using, we're pushing more from a higher level of what do you intend your network to do? Who do you want to talk to who? Who do you not want to talk to who? How do you want your network segmented? And at more of a high level, being able to define those intents helps you free up the time and know that your network is going to operate as you expect. So Apstra can take that intent and turn that into the CLI configuration for the devices. And speaking of devices, the next thing we truly believe in is providing multi-vendor flexibility, not locking you in to a specific vendor, but being able to free you up to whatever hardware you can get. So it really opens up options where you can open up your request to say, who can get me the hardware I need the fastest to be able to meet my business and requirement needs, so you can have that multi-vendor flexibility. And finally, security. So you can't talk about networks these days without talking about security. There's too many security breaches going out there, and security has to be a key element in your strategy. Now, what are we doing to take this to the next level? And that's where we're bringing what we call AI ops. And so that's AI for the operations. So what we are doing and providing, well, I'll actually show a little demo here in just a minute, is we are augmenting the Apstra intent-based capabilities, which provides a very deterministic and predictable experience for your network, by adding AI, which can provide very probabilistic, very predictive, and even conversational experiences. I mean, everybody's familiar and probably used ChatGTP or your equivalent LLM. And so being able to use that natively in your network operations experience is a game changer. And so this is where we can really bring AI ops and add AI capabilities to your network operations experience. Now, what does this do for you? And what we're going to actually see is how this works and how we bring AI for networking. And so with our Juniper solution, where we can use the Marvis AI, we can provide end-to-end visibility from your wireless access point in your campus all the way down into your data center. So you're providing that end-to-end network visibility. So that way, if somebody reports an issue, you know, is it the wireless network or is it the data center that's causing the problem? We can also provide rich insights, so that way you know exactly what's going on when there is issues. We can then provide actionable recommendations to be able to help you troubleshoot faster and use conversational interfaces via natural language processing and Gen AI with LLMs to be able to help you, guide you through the product, and be able to solve those problems faster. And we can do all of this on top of a multi-vendor solution. So who's ready to actually see some demos and get out of the slideware? So let's do that. Let me hit share. So I'm going to pull up my share here, and hopefully I'll get the right share up and going. And so what I am going to be sharing for the team is walking you through how we can use AIOps from a cloud portal to be able to augment your private data center on your own premise. So I'm logged in here to my cloud portal. What we're going to be focused on some very specific use cases, so you can ignore some of the other menu items. But I'm going to be focusing on a capability called Marvis Actions. So what Marvis Actions provides you is a overall view of your network and categories of high impact events that are causing issues in your network that have actionable results. So these are ideally the root causes that Howard was talking about, not your symptom events, but these are your root causes that are causing actual problems in your network. So what we can see here is there's various different categories. We can see several categories related to our campus, like our access points, all seem to be fairly healthy. But what we notice over here on the right is a tab called Data Center and Applications. And we have 123 issues going on in our data center. So clearly something is going on there that we need to dig into and look at. So if I click on that data center tab, we'll dive into those events and categorize them into a very data center specific view. So we can see in my data center things going on in layer 1 and 2, any connectivity issues, device related issues, things like config deviations and environmental for my CPU, fan, virtual infra integrations. This is integrations with your virtual applications that are likely in your data center, anything security, and even traffic related capacity. So we're looking at this organizational wide. So I might have multiple data centers and sites. In this case, I do. So if I look at my sites, I can even see where my data centers are located. I have one here in Dallas that has 19 issues. And then I have a couple of sites out in the East Coast in Herndon that have a whole bunch of issues. But I'm going to focus on Dallas because that is where I am located. So that's my responsibility. So I'm going to focus on my area in Dallas. And so I can see those 19 events and how they're categorized into different areas of events. Now I'm going to focus on a specific one. I'm going to start with incorrect cabling. And we can see I have 2 events here, one on a leaf, one on a spine device. And if I click more details, I can get information that Apstra has gathered from the device and from our network that tells us that we have an incorrect cabling on a leaf that's on a connection between our spine and the leaf. We can tell what fabric blueprint it's on, interface names, what was expected, all sorts of exciting, interesting details. But now, how do I fix this? What do I do to resolve this? Well, this is where the LLM comes in handy, and we can ask it, how do I check this? But first, I'm going to look at what's the recommended action. So for this event, we can see the recommended action is, as you would expect with an incorrect cabling type event, check your cabling map and use things like LDP to see if something is wrong. So I don't know how to check LDP in Apstra, but what do I do? Well, there's this little Marvis icon on the bottom right, and I can click it, and it fires up a chatbot. And so I can ask it, how do I check LDP data? And it'll go out and check all of our documentation on Apstra, and it can then tell me exactly step by step, how do I do this? So here we can see a summarized data. There's links below that take us to our product documentation, but this nice summarized data says, all right, navigate to your Apstra and go to staged, physical, links, and then there should be a fetch discovered LDP button. Well, let's go give that a try. So in that details, there's a little link to my Apstra, which is my portal for configuring and managing my network. So I'm going to fire that up. And what we'll see is, as we would expect, we see those same events in our fabric. We can see what our fabric is. I have a couple of spine and leaf devices. But let's see if we can fix that issue. So let's see if let's check those notes. How do I go and fix this? So I go to staged, physical, links. All right, let's do that. We go to staged, physical, links, and look at right here. There's that fetch discovered LDP button. So let's check that out, see what happens. So I'm going to click that button. It immediately discovered I have one link that is configured that I told it on how I want it mapped that is different than what is actually physically cabled. So let's update my cabling map for what I expect to happen. And what it'll tell me is it's updating an interface from one to the other. That sounds great. Let's do it. And let's actually commit and push that change. So the way Apstra works, quick insight for those that haven't seen it, is we have a concept of a staged and an active. As the name indicates, staged is our playground where we can make changes. Active is what is on our productive active network. So then in uncommitted, I can see the changes. So if I look at the full difference of changes, I can see it changed an Ethernet interface from E2 to E3. Yep, that's what I expected. So I can commit that change, and we'll now push that to our active deployment. And what we'll see is various anomalies. If you caught it quickly, the cabling one dropped real quick because we fixed those. We'll see things like BGP and our route anomalies here stabilize in a few seconds as the network stabilizes now that we've told it and configured in the configuration the right cabling map for how it's actually physically cabled. So now I'm going to go back to my cloud portal and look at from an organization level. That number dropped. It was around 120. It now dropped. If I look at sites, I've now fixed my Dallas site. Success. I've now used the AI capabilities to detect problems, to be able to help me troubleshoot and understand how do I go in the product to be able to fix it, and then actually go and fix it and see it resolve and my number of issues go down. So with that, let's go back to our content, and I think we'll see if we get any questions. So I think we're gonna, John, move to any Q&A.
We do have a few questions for you, my friend.
Awesome.
I want to remind attendees that you can still type your questions into the Q&A box. We'll do our best to get to all of them. Let's start with this one from Arnie. Is the existing Apstra product going to become a cloud application?
That's a great question. So there's no plans to actually make Apstra as a cloud application. There's a lot of reasons why we want to keep it on-prem. In summary, we want it to be close to the devices it's managing, and we want to be able to capture a lot of the telemetry that Apstra can gather and keep that stored on-prem for any privacy concerns, regulatory reasons, and only extract the relevant data that we need and anonymize it to the cloud. So that way you can keep that control on your own private network and be able to provide reliable capabilities. What we want to do, and what you saw, is augment the on-prem component of Apstra with cloud capabilities to bring the AI capabilities that everybody's looking at that will help with everything we talked about, from being able to reduce the time to resolution, as well as maybe even reduce the time to innocence, because the network always gets blamed for being the problem. So sometimes it's not always the network's problem, but that's where we're going towards is how can we augment the on-prem component of Apstra with cloud services and AI ops. It's a great question. What's the next one, John?
Okay, we've got one here. You bet. We've got one here from Eric, who's wondering what product lines are supported.
Excellent question. So when I talked about multi-vendor, what we focus on is the top data center switching vendors. And so those are, including Juniper, include Cisco, Arista, and Dell devices. And so Dell is based on the Sonic open source NOS platform. So it gives you 4 different vendor choices from Juniper, Cisco, Arista, and Dell. Excellent question. So John, Do we have
Okay.
others?
How about another one? Yep.
Yeah.
We got one here from Zeke, who's wondering when will the integration with Apstra plus Marvis be available?
Ah, excellent. So what I was showing, if sounds like some people were pretty smart and picked up on it, is on an integration testbed. So we are actually going to release it next week for general availability. So we are just days away from actually being able to have customers on it. We have a few early beta customers using it, including our internal IT here at Juniper, being able to use these capabilities. But next week, we'll get this out for the public to consume it. So reach out to your Juniper team if you are interested in being one of the early adopters if we get it released. What's next, John?
Okay, we've got a skeptic here is wondering, can AI really help internet-based networking solutions like Apstra?
So great question. And actually, I think there's a benefit with how Apstra is designed because it is intent-based, and what it has underneath the covers is a graph database. So without boring you on technical details, a graph database provides relationship information of everything in your network. So from ports, devices, interfaces, all of that is modeled in a graph database. And the advantage that brings when you start adding AI on top of it is you have all of that knowledge. Because as we know, and everybody's learning, AI works better with the more and more knowledge it has. As we've seen with some, public announcements with AI, when you don't have enough data to train it on or enough knowledge for it, it sometimes gives kind of kooky, weird answers. And so the advantage we can bring with Apstra is that graph database can really provide the relationship information for AI to provide value to those network operations. That's a good one. What else do we have, John?
Okay, here's another good one. You talked about AI ops, but Annie's wondering why is AI ops important?
Yeah, that's a good question. So why is it important? For a lot of the reasons that we saw in the survey, what people want to do is to reduce costs. They want to reduce their overheads. They want to free up their time and resources for their key people to be able to drive, there you go, pull those survey results back up, to be able to focus on other things they want in their business. And like Howard said earlier, not everybody is in the in the IT business. And for like the financial example, if they can reduce their cost and their overhead and time to fixing issues, they can focus on their key business, being a financial institution, and drive their company and accelerate growth. So it's really everything that we saw here is why AIOps is important, is to improve and increase velocity, make things more reliable, reduce the time for troubleshooting, reduce cost. All of those things is what AIOps can do if done right, can bring to the experience.
Okay, we've got time to squeeze in. So Eric has got it looks like a follow-up question to his earlier one about what's supported. He's wondering how is it licensed? Per port, per device, that kind of stuff.
Great question. So it is licensed per device. So every device that you're managing, so if you have 50 devices in your data center fabric, you need 50 licenses. So we do license it per device. It doesn't matter if a device has a few ports or a lot of ports or how utilized the device is. It is per device licensing, because for every device, no matter how big or small it is, we're providing the same kind of capabilities, the same telemetry we're gathering. We gather a lot of telemetry via polling with CLI. We get push telemetry and stream telemetry via the devices from streaming capabilities. We even get flow data from the devices. So that's why we do it per device instead of any other metric, because we provide immense capabilities regardless of how big or small the device is and how many ports and interfaces you're providing. So it is a per device license. So I think that brings us to the top, John, unless you think we can squeeze in any more if we have any more questions.
Nope, we're at the top of the hour, so that's all the time we have. Thank you, Kyle, for a great presentation. I want to thank Howard M. Cohen for an insightful presentation, and our guest, Kyle Baxter, for joining us on this informative episode. And a special thanks to Juniper Networks for sponsoring this episode. We couldn't have done it without them. Keep an eye out for our next episode, and for your Starbucks gift card, it should be coming your way in the next few days. Thanks, everyone, and have a great day.